Okay, so the last but not least talk for today. So please join me in a warm welcome our speakers for this talk. The first one is Eric Baird. He's a software development manager. Eric, hi, can you hear us?
Yes, I can.
Okay, good. And the second one is Rico Huijbers. Hi, Rico.
Hey, good evening.
Hey. And our technical expert for today is Darko Mazeros.
Hello, hello.
Hello, guys. So great to see you here. But first thing first, I want to ask you, could you please introduce yourself a little bit for our audience? And I think, Eric, could you be the first one?
Sure. Yeah, my name is Eric Beard. As he said, I'm a software development manager on the Cloud Development Kit team at AWS, based out of Seattle. I've been with Amazon for about 3 years now. And yeah, I'm very happy to be here and very excited to talk to everyone about CDK.
Okay, thank you. And Rico, your turn.
Yeah, hey, I'm a software developer at AWS working on the CDK team. I've been there at AWS for 6 years now and on the CDK team since it started, which I think by now is about 2.5 years. Always was more interested in building tools for other developers than building the application. And I'm super happy to be able to do that now on the CDK.
Awesome. And the Darko.
And my name is Darko Mesaros. I am a developer advocate based in Berlin, Germany, currently home in Serbia. I've been working for AWS for the last 5 years-ish. Started way off in premium support to solution architecture. Now I get to speak to developers and the communities, and well, today to try to ask questions to these wonderful people.
Awesome. So before we will start to hear you, I just want to ask you one question. Do you guys know that every people in Russia don't tell their AWS? Because in Russia we name it AWS, AWS. Oh, I see Darko know this.
We say in Serbia, AWS.
Okay.
In my language, it's the same. We would say AWS.
Really?
Yep.
So 3 AWS and 1 AWS here. Let's see. Okay. Don't want to stall your time. So let's the talk begin. Eric, please.
All right, great. So let's get started. So in this talk today, we're going to be talking about the AWS Cloud Development Kit, right? And we're going to actually focus on using the Cloud Development Kit in complex applications, large enterprises. You know, this isn't going to be a basic introductory level tutorial. We wanted to go a little bit deeper and talk about some of our best practices. Now, I will do a couple of slides on basic introductory information because you know, I assume that most of the people signing up for this talk at least know something about CDK, but there could be a few people in the audience who need a little bit of a refresher. So I'll just spend a few slides there, and then we'll get into some best practices. And then about halfway through the talk, I will switch it over to Rico, and he's actually going to show you some code samples to kind of demonstrate some of the things that we're talking about. So let's get started. And so what is the AWS Cloud Development Kit? So this is an open source software development framework. This is something that AWS created and that we maintain. It's on GitHub. But we do have a very active community. Roughly half of our contributions come from the community. So what CDK does for you is it's built on top of CloudFormation. And if any of you have used CloudFormation, you know that this is an infrastructure as code tool that allows you to specify your AWS resources using a templating language like JSON or YAML, right? So what the CDK does is builds on top of that and allows you to use your favorite programming language. Right now we support JavaScript, Python, TypeScript, Java, and C#. And we're hard at work on a Go implementation. We actually have an alpha version of the Go runtime available in JSAI right now. So that should be out for CDK within the next few months. So you can use an imperative programming language to describe your infrastructure. And as you can see from the screenshot we have right here, you know, we're using TypeScript, we're creating a VPC, we're creating an ECS cluster, we're making a network load balanced Fargate service. And you know, we've got on the screen here maybe a dozen lines of code, and this will represent upwards of 1,000 lines of CloudFormation. So you can do a lot of the familiar things that you like to do in a high-level programming language, like use classes and abstraction and loops, which makes a lot of tasks a lot easier. It's I think one of the big values here is that you can build these abstractions and then share them with your teammates and with other developers, so that you can continue to build higher and higher level abstractions, making it easier to build applications in the cloud. So the CDK consists of just like a couple of main components, right? We have a core framework, and this all starts with the concept of construct. And actually, this construct concept extends beyond the AWS CDK. There are actually several flavors of CDK. We have AWS CDK, we have CDK for Terraform, and we also have CDKs, which is a CDK for Kubernetes. So it starts at this low level, this construct pattern. And then on top of that, we build the AWS construct library. So we have a library of modules that is built on top of services like AWS Lambda, S3, EC2. So for most of our major services, there's going to be a class that we've written that will help you get started with using that resource. And then, of course, we have the CLI. This is your main way of interacting with the CDK. So with the CLI, you're going to do things like synthesize your application and deploy your application. So I can go into that a little bit more on this next slide. So this is going to be kind of a typical development workflow for working with the CDK. So you will start out by initializing a new project with CDK init, and then you can give it a couple of different parameters to initialize, a Typescript project or a Python project. You're going to build your code in whichever way you do that. Maybe you're using npm run build or yarn, or with Python, maybe you're just using pylint. And then what you're going to do is synthesize your templates, right? So in the synthesis phase, we're going to take all of that code you've written, and then we're going to create the CloudFormation templates that represent your resources. And we're also, I think one of the big things that CDK does for you that's really important is we handle asset management, right? So, when you create a CloudFormation application, let's say you have like a Lambda function, you're going to need the code that goes with that Lambda function. So we handle kind of like zipping all of that up and putting in S3 and handling that for you. Usually what you're going to do in a development environment after you've synthesized your cloud assembly is you're going to do a diff. You always want to do a diff and just kind of make sure that the changes to your AWS account are what you expect. You don't want to, accidentally make a change to a stateful resource and have that be replaced by CloudFormation. So you want to kind of closely analyze that diff, make sure it all looks good, and then of course you're going to deploy it. So the CDK deploy, like I said, it handles all of that asset bundling. It does the CloudFormation deploy for you and wires everything up and gives you a nice visual output so you can follow what's happening. So I want to talk about the different construct levels. So I talked about these constructs that we build in the CDK. And it starts at level 1 constructs. So these are constructs that are auto-generated. So there is a specification that the CloudFormation team puts out, the CFN spec. And this basically has a complete description of every CloudFormation resource and every property in all of those resources. So what we do is we take that and we generate a set of level 1 classes that gives you the basic CloudFormation functionality. So you're using your high-level language like Python or TypeScript, and you're creating resources like a Lambda function or EC2 instance. But at level 1, you still have to kind of do everything. You have to set up all the roles. You have to kind of do all of the properties that you would have had to type into a YAML template. You still have to do that. So they're definitely very useful. They're very complete. They cover all available CloudFormation resources. But the real value of CDK starts to come in at the next level with level 2. So level 2 are handcrafted constructs that are written by the members of my team, like Rico, and also by the community. And these tend to represent AWS services in a slightly higher level abstraction than the L1s. They're not very opinionated. You can generally do pretty much everything that service allows you to do. And we have escape hatches that allow you to drop down to the level 1 construct and the CloudFormation level. So you can pretty much do everything you can do with that service. You can do with this level 2, but we handle a lot for you. We basically set up sane defaults so that you can set up a resource with just a few lines of code. And then we do have conveniences like, let's say you have a DynamoDB table and a Lambda function, and you've created both of those, but now you need to give the Lambda function permissions to access that table. That's one line of code because that's built into the construct for you. And then at the highest level, we have level 3. So these are purpose-built constructs. They tend to combine together a number of level 2s, and they're doing something, they're generally very opinionated, very special purpose. They're doing a single thing very well and in a very few lines of code. You can remember from that first screen that I showed you, we were setting up a load-balanced Fargate service. All that's happening in just a few lines of code because that level 3 construct has abstracted away all of those details for you. And these level 3s, this is the level where in an enterprise, in a complex environment, these level 3s are really what you're going to be focusing on and what you're going to be building to share with all of your development teams. So on the next slide, I'd like to talk a little bit about the CDK philosophy because I think it's a little bit different than what many people are used to with traditional application development and traditional even infrastructure as code that's fairly modern. If you're using Terraform or CloudFormation and you've been building applications on AWS, you may find the CDK approach to building things a little bit different. So I wanted to explain that. So on this slide, I'm kind of showing the sort of traditional silos that you will see for developing an application. You may have one team who's responsible for your infrastructure, right? And they're setting up your network and your VPC. They're creating your buckets for you. Basically, anytime a team needs some new resource to be created in an account, they have to go to an infrastructure team and ask them to create it. And then we have our application developers. They're using source control. They're working on their application code, and they're basically creating some sort of build artifact. They're making a build. Here's our code. Here's the code for our Lambda function, or here's our container. And then you might have an operations team that's handling configuration and deployment. They're the ones who are going to take this build artifact and they're going to go and deploy it in the target environment, configure it. Now, in some companies, these may actually be different organizations, right? You may have an infrastructure team, and then you may have a separate development team, and you may have a separate QA team and another operations team. They could all be different teams. But as many of you are probably making the transition to DevOps and CI/CD, and these things are, maybe it's all in one team, but you may still treat them differently. You may have a CloudFormation template in one project that does your infrastructure, and then you have your application code. And then you have maybe, you're logging into a build server and doing manual configuration of environment variables to deploy to certain environments. Now with CDK, what we're trying to do is combine all of these things into one. So we're trying to enable you to do GitOps so that an application, any application that a team is responsible for, every change to that application happens with a Git push to your repository. So with a CDK application, what we'd like to see is a single repository, a single application that sets up your infrastructure, it contains all of your runtime code, it has all of your configuration and your deployment details. We're going to show you later in the presentation how you can use CDK pipelines to actually include the delivery pipeline in with this project. So that's really at the heart of the CDK philosophy, is to get everything into your code base, into one code base, into a repository, so that the team that's responsible for this service has complete control over that application, right? At AWS, we have made the transition to microservices, CI/CD, DevOps. We have this phrase that you'll probably hear very often called the 2-pizza team. There was a time when Jeff Bezos said that he didn't want to see any team that was so big that it couldn't be fed by 2 pizzas. So we tend to have a lot of very small, very autonomous teams who are free to make all of their own decisions and do all of their own deployments without having to throw anything over the fence to a separate operations team. So this slide here kind of is another example of what I was just talking about in this change of philosophy, right? Let's say that you've been using CloudFormation and you're familiar with that. So with CloudFormation, generally what you're trying to do is you're making a single template that has a set of parameters. You may have some if conditions inside that template, and then you're going to take that one template and drop that into different environments like Gamma, Beta, Production, and then you're basically going to parameterize it. You're going to send in whatever parameters are specific to that environment. Now with CDK, what we're doing is we're actually trying to synthesize all of the templates for all of those environments at build time. So instead of making parameterized, single, immutable deployment artifacts, we're actually going to put all of that configuration right in our code and synthesize all of it every time the application gets built. All right, so I'm going to go into some best practices here. And what I'm going to start with actually is fairly high level, and the next few slides are not necessarily specific to CDK, but I think this is very important because with CDK, what we're trying to do is enable you to adopt modern development practices. And in order to do that, your organization has to reflect that, right? There's something called Conway's Law. I think it was in like the 1970s, some guy named, I think his name was Melvin Conway. Basically, he said that an organization tends to produce software systems that reflect the organization. And at Amazon, when we made the transition from a monolithic application over to microservices and DevOps, we found that we actually had to change our org chart. Like we couldn't just move away from a monolithic application without moving away from a monolithic organization. So it's important to talk about and think about your organization to get you set up for success with using CDK. So one of the first things that you want to do in a large enterprise, in a large organization, is if you don't already have this, you want to establish a cloud center of excellence, right? And this can go by a lot of names. You might know it as your cloud infrastructure team, or your DevOps team, your Cloud Tiger team. Every company's got a different name for this. But a cloud center of excellence is basically a small group of people. It doesn't have to be a large organization. Small group of people who they're your experts. They're your AWS experts. They're your CDK experts. And they're the ones who are going to be establishing your best practices and establishing your guardrails and putting together, shared libraries that the rest of the organization can use to produce applications in a consistent way. So this is a very important part of the organization. And it's important for this organization to be pretty close to the top of your company. Generally, the person who is running your CCOE should probably be reporting to your CEO or your CTO. They're very high up because they need the authority to basically have all of these best practices followed by the rest of the organization. And one of the first things that this CCOE will want to do is to set up an AWS landing zone. So this is one of the best practices we're going to talk about later, but you should always be using multiple accounts with AWS. You really shouldn't have everything that's going on in your company happening in one big AWS account, right? Development and production and lots of different applications. You really want to create a system that allows you to have a lot of different accounts that are all single purpose. So the first thing you'll do is you'll set up a master account, and you can use a tool like AWS Control Tower to do this. Or you can just, we have AWS organizations, you can do it all manually. We actually have a service that's somewhat been deprecated by Control Tower, but it's actually called AWS Landing Zones. And at the end of the talk, I'll actually include a link to a CDK project that sets all of this up for you. So anyways, the idea is you have a master account, and then you'll create things like you'll have a log archive account, you'll have an audit account for your security auditors, give them a very secure place to log in and then do research and investigate security issues. But the really important part here, and the one that you're probably concerned with as developers, is the provisioned accounts. So it's very important that no matter what tool you're using, if you're using Control Tower or just organizations or whatever tool you use here, you need what's called an account vending machine. So development teams need to have the ability to create their own AWS accounts at will. Like say a development team decides they're responsible for creating a new microservice, they should be able to spin up a shared services account and target accounts for beta and gamma and production without and it's all on a self-surface basis, right? You don't want them to have to go and make a request with another team, wait for another team to do this. So this is where your CCOE comes in, because you build this in a way that when those teams create these provisioned accounts, they've got all your security guardrails in place. So those teams have relative freedom within the accounts to do what they want and solve problems in the way that they want to. But you put some guardrails around that to make sure they don't do things like, maybe your company policy is you're not allowed to have any public S3 buckets. And any data source that you create, like a Dynamo table, has to be encrypted at rest. You can enforce all of this in these provisioned accounts that you create. So our next best practice, like I just mentioned, is deploying to multiple accounts. And this model right here is kind of what we're going to demonstrate with some of our code samples later in the talk. So, in a typical service team, we're responsible for some microservices. So maybe me and Rico are working together. We're doing our development. I'm deploying code into my own AWS account that's been set up for me so that I can do my development and testing. And Rico's doing the same thing. And then, I will check some code into, let's say we're using GitHub, and I check my code in, and then Rico does a code review on that. But once things get pushed into our master branch, that's when the pipelines that we've developed in our shared services account, we'll pick that up, we'll do our build, we'll run our tests, we'll synthesize our cloud assemblies, and then begin the deployment process out to our target accounts, which on this slide you can see we have a beta, a gamma, a prod. Of course, you can call them whatever you want. These are fairly typical names. Maybe you call them staging or testing account. But what's important here is that this shared services account is single purpose. That's what it does. It watches source control, it picks up those changes, it does our builds, and it does all of our deployments for us from that one account. And then each of our target accounts, beta, gamma, prod, is also separate. This is really important. And I think one of the biggest reasons is limiting blast radius on changes, right? The last thing you want to have happen is to have a production outage because you also have development and test in the same account. And let's say somebody accidentally spun up 1,000 EC2 instances in a development environment, right? But that's in the same account. Well, what happens when production needs to auto-scale and now you've hit a service limit, right? You may have a production outage because of something happening in development services. So you want to keep that stuff in a separate account to limit that blast radius. And like I mentioned, the last human gate to your deployments should be a code review, right? You want to really optimize the development experience so that developers can work quickly, they can write code locally, they can deploy to an AWS account, and really you want to start treating your AWS account as an extension of your workstation, right? So you're deploying into that development account, you're making sure everything works, then you push some code, ask for a code review, and that code review is the last time that a human being steps in and has a decision to make about whether to allow that code to continue. Once we've gone past that point, and this part should, like I said, be optimized to be very fast. You want to have very quick iterations on building and developing and testing and reviewing code. Once we get to that point, then that code gets picked up by that shared services account and you begin the deployment process. So your goal here, and we will show you how to do this with CDK just a little bit later. Your goal here is to fully automate this process. In many traditional organizations, when a development team kind of finished a release, now it's time to turn it over to the QA team. And now the QA team goes and does a bunch of testing, and they come back with maybe some bugs they found, and you go back and forth, and you finally are able to release your software. And it can take a long time to make this transition. It's not easy. It won't happen overnight. But your ultimate goal is that everything here on this slide is automated, right? We're going to do our builds and our CI and our unit tests, and then we're going to deploy into the maybe an alpha environment or a beta environment. And then we're going to run some integration tests. If all of those tests succeed, then we're moving to the next phase, maybe beta or gamma. And then we're running a series of more and more realistic tests the farther we go. So our gamma accounts, the way we treat gamma accounts at Amazon is an environment that is very, very close to production in its configuration. And that's where we're going to run our synthetic tests. These are the kind of things where we've sort of maybe anticipated what a human QA team would have done, and we try to run all of those kinds of tests in this gamma environment. And once all those tests pass, now we're moving right to production. And this phase here, where we go from gamma to production, is where a lot of companies will still have a human gate. They will say, stop here, wait until a human being approves this. And that's okay. It's one of those things, like I said, this transition can take a long time, but eventually you want to find ways to remove that human gate and move your automated deployments right into production. And you may deploy those changes in waves, right? Let's say you're using fleets of EC2 instances in multiple regions. Maybe you'll deploy this change to a single EC2 instance, and then to a single fleet, and then to a single region, right? A full rollout of a feature at AWS could take days, right? So you have development teams who are doing multiple deployments a day, multiple check-ins. This process is continuously running, but any single code change could literally take days to fully roll out because we're being very careful. Like I said, we needed to optimize our development cycles for speed. This is where we slow down, right? It's okay to go slow here and to really make sure everything's right before you move to the next phase. And so to enable this automation, you really need to measure everything. And we'll talk about some ways to use the CDK to do that just a bit, right? You have to measure, to do full automation, you have to measure way more than you think you do. I think we're used to setting up, maybe we'll watch the CPU, we'll watch RAM usage or disk space, but we want to incorporate every metric we possibly can into our automation, right? We may actually use business metrics. You may have an automated rollback that's based on the fact that your website suddenly has 50% less signups today than it did yesterday, right? It may be that you've hooked this business metric into a CloudWatch alarm and you're halfway through a production rollout and suddenly your signups drop off, which means, hey, maybe we messed something up on the homepage. Maybe suddenly users can't sign up or it's harder for them to sign up. And you may just automate a whole rollback of that release just based on that business metric changing. So it's really important to really think ahead and try to measure as much as you possibly can. And at this point in the presentation, I'm going to turn it over to Rico because he's going to continue our best practices and now start talking about how the CDK comes into play to help you implement these.
Right. Thanks, Eric. Yeah, so let's have a look at how the CDK can help you achieve all these things we just talked about. I think I have control. I do. Sweet. So the first thing I want to get back to is that Cloud Center of Excellence that Eric was talking about. So the primary goal of what they do, right, is to share their knowledge, share their patterns, share the best practices inside the organization. And that is, I mean, that is exactly what constructs are, right? Constructs are an executable embodiment of this kind of knowledge, of these kinds of best patterns. Your developers are going to use a number that we created. Maybe they're going to use constructs that other developers created and share it out on the internet. But they should definitely also be using patterns that make sense for your organization. And the CCOE can encode these to make the developers more productive and help them achieve their goals in, like you saw at the start, maybe a dozen lines of code instead of hundreds it would have been otherwise, already filled with best practices. So to share this out, you can use any number of tools that you might have in your organization already. AWS has AWS Code Artifact recently released. You might already be using Artifactory, or you might be using GitHub packages, like many different solutions you can use to, once you have this executable code, to share it across your developers, just like you would do with any other code. And it doesn't have to be a one-way street, right? Your developers among themselves can. I'm not seeing the feedback here. I'm sorry. Okay, yeah, they can share amongst themselves as well, right? If a developer team comes up with a pattern that makes them more productive, they should just send that back and share it out with the other developers teams inside your organization as well. And after a while, your artifact repository is going to be a treasure trove of patterns and reusable classes that are going to make your developers way more productive. And I want to stress that this is not about compliance, right? This should be about empowering developers and empowering developer productivity. It's not the point that the CCOE will say, oh, you must use our construct to build this. We have other mechanisms that we will get to later if you want to enforce best practices and enforce certain compliance rules across your applications. You definitely should, but this is just about getting the most efficiency for your developers. If they need to, for some reason, deviate from some of the pre-built constructs, they should, as long as they stay within reasonable compliance rules, and we have other mechanisms to guarantee that. So let's look at the kind of constructs you could be vending. So the L2 constructs are vended by us, and they do reasonable things for many of the resources. They have sensible defaults. They make it easier to work with. You can build something on top of this that we call the level 2.5 constructs. And we see many customers do this. They make a copy of a DynamoDB or an RDS construct, and it'll just have some defaults that make more sense for their organization. It should be said that if you do this, and especially if you enforce it right, which is why you shouldn't do that, you would cut yourself off from the construct ecosystem that gets built across the internet, because they will be using our level 2s and not yours. So you definitely shouldn't mandate this. You might do it for convenience if it helps. But really where the value is, right, is in the L3s, where you would make your developers just plug in a couple of business logic rules, right? You have a couple of holes where the business logic goes and the rest is basically pre-built. And stuff just gets to production in no time. And it can be like a secure REST API, a CloudWatch tokenesis pattern. It can be a number of things that you could have here. So when you're building construct libraries, there are a couple things to keep in mind, and let's go over a couple real quick. The first one, I don't want to say is a you must do this, but you should consider doing this. And especially if your organization uses a lot of different programming languages. One of the things we do for CDK is offer it in 5 languages at the moment. And it's not that we write it 5 times. We write it 1 time, and then we make it available in other languages using a technology that we call JSAI. And this is open and it's available for you to use. So if in your organization, your developers use a variety of languages, you can use JSAI to build these constructs and make them available, make it write once and use everywhere. And even if you do this, we have other tools that can be very convenient for you, such as a tool called JSAI Diff, which check when you release a new version, check whether you changed anything in the API of your construct so that existing users would be broken, right? So you can check the compatibility of your new release with your old release and make sure that your updates can keep on flowing and everybody can just upgrade to the latest version all the time and get any fix that you might want to add. Something that people ask us a lot is whether they should be vending constructs or stacks and in their construct libraries. And I want to be very firm on that. So stacks are for application builders, and they describe a deployment layout. So what you should be doing if you're building construct libraries is vend constructs. And then an application builder can take that construct and put it in a stack by itself, like maybe you would have vended in the first place. But they can also say, well, it makes more sense in my case to collect a bunch of constructs together, put those together in a stack, and then deploy that. So this is strictly more expressive. Next is, where should a construct obviously need some configuration, because that's where the power comes from. You have a part of a pattern, and then there are some holes that the user can plug. How do you configure it? We see some people using things like environment variables to do something like that. But we have a pattern that we recommend you follow. Is all constructs get a set of properties when they get instantiated, and that completely describe how it's going to behave. There's no external state, no global variables, no nothing. And that obviously has the advantage that it's very obvious where the knobs are that you can tweak on this construct. They're just going to be in that property object that you can see. We like to think of constructs as like a pure function of input to output, right? Where it's like a clear set of inputs, and then that leads to a single output, which is a resource definition. And that also helps a lot with testability, which is definitely also something you should be doing, and you now can do. The CDK comes with a library for this. It's called the assert library. It makes it very easy to make assertions on the constructs that you have in your construct library, or the resource definition that get generated for it. So this is now something you can do and should definitely take advantage of while writing construct libraries. And in particular, you should be checking that you're not changing the identifiers of stateful resources that you create. Because the identifier represents the identity of a resource. And if you change it, what's going to happen is the downstream execution engine is going to say, well, this old resource that I have with this ID no longer exists, so I better delete it. And a new resource with a new identifier needs to be created. I mean, it looks suspiciously like the old one, but the execution engine can't tell that. So it will delete and create a new resource. And usually that's fine, right? But if this is a stateful resource, like a database table, you've just lost all your data, right? So that's not what you want to do. But fortunately, you have this unit testing mechanism. You can test that you're not doing that between updates. And then finally, and I already mentioned this before, but constructs are for convenience, right? Constructs are for making developers more effective. If you want to use them for compliance, there are better mechanisms for that we'll get to later. So this is the construct vendor or the construct author, library author side of the story. But let's talk about the application developers themselves. And they're the people that are going to be using your constructs from AWS, from the internet, from inside the organization, to put together into an application that gets deployed to AWS. So a number of these actually are the same as for the construct library, for the construct libraries before. configuration via properties is definitely something you should still be doing, and unit testing is obviously something you should still be doing. But something that's specific for an application is, in the past, you would sometimes see that people would hard code resource names, and they would say, my table is always called, my table, and I put that string into my code. Now, if you always create a resource with the same name, there are a couple downsides to that. So one of them, obviously, is that you can't deploy the entire application twice, because you can't have two databases or two tables with the name my table. And another one is that if you want to make a change that needs the table to be replaced, right? And that means you want to change a property about it that can only be configured in the create call. That means we need to create a new resource and delete the old one. But if the new resource is going to have the same name as the old resource that already exists, because it's going to happen, for safety reasons, it's going to happen in the order, create the new one, and then only if the deployment succeeds, delete the old one. Well, the new one can't have the same name as the old one because that already exists. So a better way to get around this is to just have names automatically generated for you for everything, and then just parameterize your application so that it takes the name as an argument. And there are a number of ways to do that. You could do it via environment variables, or you create a config file on startup. I'm going to show you an example of that later on. Another one is, we were talking about stacks, and stacks are a deployment mechanism. But what constructs do I put in a stack together? And generally, I would say put everything together in one stack as much as you can, because it's way more convenient, and it just deploys nicer. Sometimes you want to separate it out, but make sure you have a good reason to do that. So, for example, sometimes you want to separate a resource out because it's stateful and you want to protect it a little more. So again, I'm going to use the example of a Dynamo table. I want to put that into a separate stack because in that stack I can enable something like termination protection, which makes it very sure that I don't accidentally delete that stack or anything and thereby lose my state. Or sometimes you want to have dependencies between stacks, and you need, for the dependency order to work out, you need things to be in a separate stack because you can't have cyclic dependencies between stacks. They must be deployed one first and then the other. So only the second one can depend on the first one and not the other way around. If you want to change this, the layout of constructs between stacks, you can. Right? It's going to entail some recreation of some resources, but as long as they're stateless, that's fine. You can always change the decision later, but make sure you do it for a good reason and not just because you feel like you should. Sometimes your application needs information from the outside, right? You can't just, what's in the code is not enough to synthesize a complete application. For example, your application might depend on the number of availability zones you have available to you. You want to do something for every availability zone, such as create an EC2 instance in every availability zone. That's fine. And what you could be doing is you could be doing a network lookup inside your application, and then based on that lookup that tells you how many availability zones you have, create your infrastructure. But the problem with that is that the answer is not stable, right? AWS is always changing. Tomorrow we could be adding a new availability zone just in that region available to you in your account, and that network call is going to be returning something different. And now your infrastructure is different, and it might be at a moment you're not ready for this change. Maybe you were just doing something else, and now something unrelated changed. That's something you don't really want to do. So just like a construct, you actually want your application to be deterministic. You want it to be a pure function from its inputs to its outputs. So how do you handle this extra information that you need? So CDK is a mechanism for this, and we call it the context mechanism. So what's going to happen is the CDK CLI is going to do the lookup for you, for example, the number of availability zones, and it's going to remember that the answer to their question, and it's going to store it in a file called cdk.context.json. And in the future, it's just going to reuse that same answer it got last time around until you do an explicit command to say, hey, I want to update this, because maybe now you know there are additional availability zones and you want to spread out to them. Or maybe it's an AMI ID, if you're a Windows 2019 server image in a particular region. This does mean that you do have to check in this cdk.context.json file. You get this question quite a lot, and it's meant for this. Please keep it with your source code, because this is like a record of all non-deterministic decisions that needed to be taken to make your application synthesize a certain way. One of the very convenient things that CDK can do for you is automatically generate least privilege permission roles. So for example, if you, like your Lambda function needs access to a table, that's one line of code, as Eric already said, and it's going to have access to exactly that table, it's just by its ARN. It's not going to have any star in there or anything, right? And this is just a real good way to be safe. But it does require that CDK is allowed to create and manage roles. We see some organizations where they're not comfortable doing that, and they want to say this DevOps team, the CCOE team, creates the roles for you, and here's an ARN, and you import that into your application. But it's going to be very hard to do that, to either scope that correctly or have a flexible and quick deployment cycle. If you're not comfortable about this and you want to restrict the role some more, you can. There's a better mechanism than having it created by a single organization, a single team in your organization. You can use permission boundaries to make sure that the role can never escape a certain set of, the role that you get for your Lambda can only do things that make sense and not, for example, create additional roles, which you generally don't want it to do. And then finally, something else we see is that some people have an application, a CDK application, that represents a single copy of their application. CDK, I should say, a CDK app that represents a single copy of their application. And then they're just going to CDK deploy that 4 times. Once for beta, once for gamma, once for prod, right? And maybe there's a second prod. What we recommend is you do it differently. We recommend you model all the production stages, all the stages of your application inside your single application. Because when you start doing that, you can now also start modeling things that aren't, strictly speaking, part of the application itself. You can model things that are global, like maybe there's a global monitoring system that you want to model this way, or, like you should be doing, a pipeline. Right? A CDK pipeline, and this is one of the fancy L3s we vend, you model it next to all the application stages in your all the stages of your application, and it's going to create a pipeline that deploys to all of them, and it needs global knowledge to do this. Now, some of the fancy I should say innovative things about CDK pipelines are that, first of all, it goes with your application, so it lives right next to it, and the whole Git repository is self-describing. And because the whole Git repository is self-describing, this pipeline actually modifies itself. So the description of the pipeline is in the application. When it pulls the latest update of your application, the pipeline reconfigures itself to deploy the latest state of your application, adds any assets, any deployment stages that you added in your last commit, and then proceeds to deploy them. And because this is so important, as Eric already mentioned, that you separate out your different application stages across different accounts and different regions for isolation purposes, this is actually super easy in CDK pipelines. And literally, the only thing you have to do is say, here's a copy of my application. It needs to go to this account and this region. And then there is some setup that needs to happen in code pipeline land, but the construct library takes care of all of that for you. And we're going to see an example of that later on. So let's get into code samples, right? I have an example application that I want to deploy. And this is an architecture that many of you will probably have been deployed in the past. It's going to be a simple dynamic website. So it's going to be a static component, which is some HTML files that live in an S3 bucket. And the dynamic part of the website is going to be serviced by Lambda. That's triggered by API Gateway. And all of that is fronted with CloudFront. Any state for the Lambda goes into Dynamo, and then because we want to serve this over HTTPS, there's going to be a certificate that's going to be created to put on the CloudFront distribution. And then obviously, because we want to monitor what's going on, we'll have a CloudWatch dashboard, and it's going to be monitoring the Dynamo table and the API Gateway. Now, the first thing I want to think about when I'm thinking about this application is, how do I lay this out into stacks? And in this case, I'm going to decide to put the DynamoDB table and the certificate together in one stack. I'm going to call this the stateful stack, and I do this specifically for the reason that I already mentioned before, so that I can enable termination protection for this stack. I don't want to accidentally delete this. First of all, for my table, there's user data in there, so that would be bad. And for the certificate, you need to do some manual work when you create it, like prove that you own a domain and everything. There's some. I'd rather not lose it. I mean, I guess it could go in the other stack, but I prefer it to be nice and safe in the stateful stack that cannot be deleted. And then the rest just goes into a stack I call the web app stack. And this is all the stateless resources that make up my application. If I want to, I could throw this away and recreate it, and that would all be fine. Technically, you would say the S3 bucket is stateful, and so it is, but in this case, I'm not using it in a stateful way, because the only thing, it doesn't contain any information that doesn't live anywhere else. It's just gonna contain HTML files that live in my Git repository, and I just put them there in a way so that CloudFront can serve them. So I'm treating this as stateless. It can go away and I can recreate it from scratch, no problem. And then finally, the monitoring stack. I put that at the end. The dashboard goes by itself because it will have references to the other resources. They will have generated names. And so CloudWatch is going to monitor the table and the gateway, and it needs to be deployed last. So now I have a nice deployment order. First a stateful stack, then a web app stack, and then a monitoring stack. And I don't even need to pay attention to this as a user, because CDK is going to figure out the right order for me and deploy everything in the right order anyway. So let's look at those different stacks in order. First of all, I invent a small protocol for monitoring. And I do this because I want a global dashboard that shows my entire application. And I want a way for the individual stacks to add themselves to this global dashboard. I can make this as complex as I want, right? But for now, I just say add graphs, which allows these stacks to add widgets to a global dashboard. So this protocol is implemented by the monitoring stack. And there's a bunch of code here. I don't want to get into all of it. It's not very important. But what I want to call out to you is that the monitoring stack has a dashboard, and it implements this add graphs method from the interface. The implementation I hid here, it's very much what you would expect. So let's get on to the stack that contains my state. First of all, I decide what's going to be configurable about this, right? And this is how I make a properties object, what we call that, and we say these are the arguments to my stack. So first of all, it takes that monitoring interface that I made on the slide before. And then I say the domain name for the certificate is a parameter. And I'm going to make that optional. So for the production stacks, you do want to give this, but I want to give myself the opportunity to also deploy this as a developer for testing. And maybe I don't want a domain name then, right? And I can just do without. CloudFront's going to generate a URL for me, and for testing my application, that's fine. So this is one of the best practices I called out, configure everything with properties. Let's look at the implementation. It creates the stateful stack contains a table like we already said, and it conditionally, based on that if, right, creates a certificate with a domain name that I put in there, and otherwise it doesn't. Now, to create the certificate, we need the hosted zone ID of the hosted zone that it's going to use to validate this. And this is interesting. Here is where we're using the CDK's context mechanism to look up this hosted zone and make sure that answer stays the same. This is going to do a network call one time, and after that, the answer is going to be in cdk.context.json, and I won't have to worry about that again. So this is one way to make my application deterministic by using this context mechanism. And finally, what the stateful stack does, right? It uses this monitoring protocol to add a bunch of graphs about itself. Right? We want to show errors. We want to show read capacity. And notice how the CDK has autocomplete here on all the metrics that are available on this table. And you can just, from your editor, you can just go and explore the metrics that are available and add them to your dashboard. And I should probably also have added alarms here. I wish I didn't, but it's probably a good idea. Right? So this is measure everything. And finally, the web application stack itself also has a number of arguments, like the table. The data is going to live in the domain name and certificate, if applicable. And finally, again, the monitoring. And here's a part of the implementation. Now, again, there's a lot going on here, but I want to particularly call out two things. First of all, this, right? As we said, we don't want to hard code the table name. And how could we? Because it's a parameter. But what we do is we use an environment variable to pass the table name to the Lambda function. And now the Lambda function could use any table name, and in this particular case, is going to use this table name, right? So avoid hard coding, but instead parameterize our application for generated resource names. And the second, I want to call out this. This is what we do to give our Lambda function permissions to read and write to the Dynamo table. Again, the one line of code generate minimum least privileged permissions on the execution role for the Lambda function. And this is all possible because we allow CDK to create that role for us. Now that we have all three of our stacks together, this is a whole copy of our application, but we want to bundle this up into a single unit so that we can deploy it multiple times. So what we do is we basically draw an additional box around it, which is going to become its own construct, representing a single copy of our application. And in CDK land, we call that a stage. A stage is just, again, another construct that has props, in this case, again, that domain name, and it's implemented as follows. We instantiate those three stacks. Specifically for the stateful stack, this is where we enable termination protection. And for the web app stack, this is how we hook up relationships between stacks, right? One of the parameters to the web app stack was it needed a table. That table is going to come from the stateful stack, and this is where we hook that up. And same with the certificate. Now that we have a single copy of our application, right, in a class, we can simply instantiate that copy multiple times and then make a pipeline to deploy all of them. The pipeline needs to be deployed itself as well, so it also lives in a stack called the pipeline stack, which is again a construct. And this is what that looks like. So in this thing, we're going to make a pipeline, and it has two important parts to the definition, which is where the source lives. And in this case, the source lives in GitHub, how it's compiled, and in this case, it's a standard compilation for an NPM project. And now the meaty stuff happens. This is where we tell the pipeline to deploy a copy of our application. And we instantiate that stage that we just defined, we give it a name, and then we tell it where does this need to go. And it needs to go to a particular account that we know is our beta account. And it goes along with the parameter domain name for the domain that we use for our beta stage. And we do this for every other stage in the application as well. So this, because we model our production stages, we can now model stuff that is not part of a single application, but part of our global infrastructure. If you do that, what you're going to get, we're going to run through what the pipeline gets you real quick, is a pipeline that pulls from a GitHub repository or a Git repository that your developers push to. First step in the pipeline is going to be synthesize. Same as you would do in your developer desktop, compile the application and run it to produce a description of your infrastructure in there. Now, because, as I said before, the application contains a definition for itself, for the pipeline, it might be that the application is going to modify the pipeline in flight. And what this is going to do is add anything to the pipeline or remove anything that no longer applies. And then it just proceeds to deploy the rest. First step is, or the next step is publish assets. And an asset is anything that lives in your source repository, but needs to go to an external storage place like S3 or ECR first. And we use this for our Lambda function source code. We use it for Docker images. They get built and then pushed into the right location so that the next step is a CloudFormation deployment, uses those assets in that S3 bucket that was put there before. And this happens, again, to a different account, right? This will be to our beta account or gamma account if we want it. Afterwards, what you should be doing, what I did not do in this example, what you definitely should be doing is running tests, right, before you proceed with the next deployment. But then that's it. And these two steps just get repeated for gamma and prod and the rest. Final piece of the puzzle. We said you're going to use the pipeline to deploy production stacks, but then CDK deploy a local copy of the application to your own developer account. We instantiate the stage object one more time, and this time we tell it to use the account and region of the CDK CLI. So these environment variables will be put there by the CLI, and they will be your account and your region as configured in the AWS CLI. And the domain name, in this case, can also come from an environment variable, right? If I set it, I will get a copy of my application that uses a domain name if I have that set up. And if I don't, then I'll just get one that uses an auto-generated CloudFront URL, which is also fine. And this should be the only place where you're using environment variables. This is the entry point of your application. This is where you use environment variables. You put them into properties, and from there on out, between the constructs, it's all just properties. And I also define the pipeline stack here because that needs to be CDK deployed once before it will start managing itself. Now, one final thing I want to touch on. I said before, that constructs are about convenience and not about compliance, right? Constructs are about making developers more effective and more efficient. How do you make sure that what you're deploying is actually in line with the security and compliance guidelines of your organization? There are a number of ways for this. In the CDK itself, we have something called aspects. And an aspect is a visitor, basically. It gets called for every node in the construct tree, and you can make it do anything. Right? And you can make it check the properties of, for example, in this case, a bucket. What this visitor is going to do is it's going to check if versioning is enabled on your buckets. And if not, it's going to add an error, and now you can deploy your infrastructure. You could also have it do something else. You could also have it enable versioning if that's what you wanted to do, right? Just force it on, don't add an error. You can make this do whatever. So this would be a way to check that the application that's defined in CDK does what you need it to do. And there are alternatives. CloudFormation recently released something called CloudFormation Guard. You can write rules that you can run on a CloudFormation template, which you can also use to achieve these kinds of compliance rules. And then, of course, we also have config and inspector as services. Finally, as Eric already mentioned, CDK is open source and on GitHub. And basically half of the commits in there are from community members, not ourselves. I would also call out as a best practice, if you have feature requests, if you have bug reports, please tell us, please file an issue. If you want to contribute, you're more than welcome. We appreciate everything. You can create pull requests and they will get merged. Then finally, this is a slide with a number of links to things that we mentioned. We have a CDK workshop, which is good for getting started. There are a number of samples, sample repository that we have with a lot of how-tos on how to set things up. And then there are a number of blog posts. And of course, right in the middle, there is a GitHub repository with the sample code that I used in this presentation.
Okay, I think you're back.
I dropped out there for a minute.
Yeah, it seems so. I think this is time for Q&A right now, as all three of us are on screen right now. So, Eric, Rico, thank you very much for this presentation. It was wonderful. I actually made a lot of notes for myself. So I guess it's time for Q&A. So for anybody watching the presentation, feel free to put your questions in Telegram. So far, there were no questions. But okay. I do have a couple of myself.
Please go ahead.
So Rico and Eric, you were mentioning that doing multiple accounts is the way to go. That's the way we talk about things at AWS, having multiple accounts, doing things across a broad sphere of it. And one of the solutions for that is the CDK pipelines. That's how you can deploy to multiple different stages. My question here would be for you. When you have your deploys, and you said you will do the CDK deploy once just to deploy to basically to the shared account with the pipeline, but if you do both local and shared, how do you handle the permissions for the two, right? Do you pass on a specific profile of the CDK CLI, or what do you do?
Right. Well, first of all, we recommend actually that you revoke access to the shared account to developers as soon as you can, right? So I would say you would give your developer permissions to deploy into that account once. And CDK has a mechanism in its bootstrapping method where you establish trust between two accounts. So you can say, when you bootstrap the shared services account, you can give the developer's account access to deploy into it using CDK. Developer would go and deploy the initial pipeline, and then you remove that trust again. And from then on, all changes to that account just go through Git, and importantly, also through code review.
Okay, got it. That's a fair point. Second question I have, when it comes to sharing constructs, how do you see this actually working between different teams? So, of course, we can all just copy paste things, but how would this properly be implemented right now? So if a team would like to use a specific construct, like for example, your your monitoring construct, right, that creates the graphs and all the things, how would a team A grab that from the CCOE?
So that's you're probably going to be using something like we have AWS Code Artifact, right? Which is our internal tool that we've available to customers, a tool that we've built that allows you to set up an artifact sharing so that you can use it from like NPM or PyPy. You can actually configure it to use Code Artifact. You could also use a partner tool like JFrog Artifactory is very popular. I believe GitHub Packages kind of does the same thing. What some companies will do is they will not only have these shared construct libraries that they're building to share with each other in this artifact repository, but they can also use it to sort of put a buffer between them and something like, say, NPM. Like you may be actually replicating everything from NPM or a certain subset of packages from NPM, and maybe they're on a delay, right? Maybe you have a security team that's able to do security audits, and then you make all of those available so that when a developer uses NPM, they can't go straight to the public resource. They have to go through Card Artifact or GitHub Pack, whatever tool that you're using. But you're generally going to want to use a tool that allows you to put all those things in one place, and then allows developers to use familiar tools, so they don't have to do something weird with their build environments. They can just use NPM or whatever they're used to.
Yeah. So you mean basically just package those specific constructs as node modules, right? In this case.
Exactly, and you can use, as Rico pointed out earlier, you can use JSII for this. This is another open source project that we built and maintain, the JavaScript interoperability interface. This is how we vend the CDK in multiple languages. We write the CDK in TypeScript, but we vend it in Python and in Java and C#, and we use the JSII to do that, and you can do the same thing. And we encourage customers that when they vend a construct, they use JSII in order to vend it out, so that if you have a development team who prefers Python, they can use Python. If you have a Java team, they can use Java.
Yeah, that was also going to be my question. When it comes to languages, how can we make sure that the right team can use the right language? But hey, JSII to the rescue, I guess.
Right. And you don't have to write, but you can write in Python, but then it can only be used in Python from then on out. So you have to be very sure that once you go outside JSII, you stay in that language, or you duplicate development effort, but nobody really wants to do that.
Yeah.
Right? But JSII will definitely give you that ability.
Excellent. No, I'm a big fan of. I've never had a chance to use JSII for this kind of a purpose, but I know the magic that it does to enable all these other languages within CDK is just the thing. Excellent. So as there are no more questions, I have nothing else. It's late, yeah. I have nothing else to add. You didn't touch up on too much on testing, or at least I may have phased the moment that you...
No, that's true.
Yeah. So I know that there's an ability to do testing, especially when it comes to JavaScript or TypeScript in this case with Jest.
Yep.
Are they assertion libraries for other languages supported by CDK, or currently is it only for TypeScript/JavaScript?
It is on. It is. We know this, and we have plans. Is what I can say about that. So the answer, unfortunately, for now, it is still the assertion library we use ourselves that we wrote is currently only available in TypeScript still.
Okay.
We want to do something about that. So for other languages, you're going to have to find a different structural assertion library. So it can be easy, or I mean, honestly, so a CloudFormation template is generally just a deep JSON structure. So if you can find any library to make assertions on a JSON structure, then that'll help you. But the one we use, unfortunately, needs some work done to it before it's available.
Okay. Thank you very much. That answered my question. I would like to thank you guys for this wonderful presentation. I guess
No worries.
the host will jump in and tell us to leave or something. I don't know. But
Turn on the lights.
Yeah, turn off the lights. Say, okay, everybody, it's time to go home. But yes, you're welcome back, Mr. Host.
Давай. Okay, so sorry for this technical pause, guys. I just have one more question for you. So you talk a lot of, and first of all, that was very interesting and very helpful. Thank you for that. Absolutely fantastic, I would say. But I have a question. How would you define the complex application? I mean, exactly complex. Which application you will name not exactly complex to use the CDK?
Wait, so is your question, would there be an application that would be too complex for the CDK, or if we had...
No, not enough complex for CDK, I mean. Where the CDK will be, let's say, it over-engineering.
I don't think there's anything too simple for CDK, right? Because what I talked about earlier was the wanting to move towards like modern application development with decomposing into microservices, have smaller and smaller units. And honestly, microservices get pretty small. I mean, you see some teams that literally will decompose down to a microservice being one function, right? And that's a perfect use case for CDK because you need to deploy that into your AWS account. I think what we find is once teams adopt CDK, they find they really like it, and they begin to just mandate that everything they do, everything that gets deployed into their account will go through a CDK application. So even if that CDK app is literally a single Lambda function that does one thing, that's a perfect use case for CDK.
Okay, awesome. Thank you for that clarification for me. So once again, it's been a great pleasure to have you here. Thank you for sharing your knowledge with us. I hope we will see you on the next conferences, and these conferences will be, let's say, in offline mode, not an online like that.
Yeah.
So thank you once again. Have a good day, or I don't know, maybe it's just a morning for you. But anyway, thank you guys, and bye.
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 Bye-bye.